Let's take a look at the derivative of the arcsine. So I'm going to show you two ways of doing this. The first way is to rewrite the arcsine and then use implicit differentiation. Then I'll also show you how to use the derivative of an inverse function theorem. That'll be the second thing, and we'll get the same thing. Okay, so we're going to start off with y equals the arcsine of x. And we're going to assume that x is between -1 and 1. That's the domain of the arcsine, and then its output is the y, which should be between -pi/2 and pi/2. So we're going to assume that that stuff's all nice and well defined. So we're going to rewrite. So this becomes sine of y equals x. So those are equivalent as long as the x and the y are where they should be. Now we're going to use implicit differentiation. And remember, the y is a function of x. And so what we'll do here is we'll take the derivative of the sine, and derivative of the sine is cosine. And then derivative of y, since it's a function of x, is going to be y prime. Now we're actually kind of using the inverse the derivative of an inverse function anyways, because here we have an inverse function, so we're assuming that that does have a derivative. But this is just another way of kind of getting at the same formula for the derivative. Okay, then the other side, the derivative of x is just 1. We're going to divide both sides by cosine of y, and the y is arcsine of x. And what we're going to do is we're going to draw ourselves a right triangle. So what the sine function does is it takes an angle and it gives you a ratio of sides of a triangle. The inverse does the opposite. It takes the ratio of the sides of a triangle and it gives you the angle. Well, the ratio of the sides of the triangle is x. And the sine is opposite over hypotenuse, so the easiest way to get x would be your opposite is x, your hypotenuse is 1, so x over 1 is x. And then we have 1 squared equals whatever this is plus x squared. So we subtract x squared and take the square root, and that's where we're going to get the adjacent side on this triangle. There we have it. Since we're not going to do the plus and minus business here. So there's that angle, arcsine of x, that's the angle. Okay, and then we're just going to find the cosine, which is going to be the adjacent over the hypotenuse, which is just going to be 1 minus x squared, so that's what's going to go in the denominator of this fraction. Okay, and there is your derivative of the arcsine. It is 1 over square root of 1 minus x squared. In your textbook, you have a little bit more generically where you have some differentiable function u of x. So we would just have to do the chain rule. So if you want to take the derivative of the arcsine of some differentiable function u, we're just going to have a u prime on the top there, and instead of having x squared, we'll have u squared. That's the only thing different by the chain rule. Okay, so it's going to be u prime over square root of 1 minus u under the square root. Okay, so let's use the inverse or the derivative of an inverse function. And we'll assume that all the assumptions are made for this to be valid. So when I want to take the derivative of the inverse function, it's going to be 1 over the derivative of the function composed with the inverse function. So if we start out with our original function is the sine, the inverse of the sine is the arcsine. The derivative of sine is cosine. Okay. And then we'll use the inverse formula up there. So f inverse, take the derivative, it's going to be 1 over f, which is cosine. I'm sorry, not f prime, which is cosine, evaluated at the inverse function, which is the arcsine of x. And this is going to give us the exact same triangle we saw on the previous slide. Okay, and there you have it, two ways. So in your homework assignment, I'm going to have you do derive the arc cosine in a manner very, very similar to this. So if you can follow this, you'll be able to do the derivative of arc sine just fine.